Hi all, my name is Madhu and I'm here to present a research demo on exploring frontiers of AI agent in semiconductor and hardware design industry by building a Copilot agent. Let me discuss the current crisis which the modern chip designing industry is facing. Chip design process is very complex. It's an iterative process and it requires domain experts and collaboration among the specialists. Extensive documentation, meticulous verification makes it very time consuming and it is more prone to errors. Traditional design techniques are labor intensive, leading to increased costs and delays in product releases. Hence, there is a dire need for a novel approach to handle all these complications. With emergence of AI agents and agentic AI, which is taking the world by storm, it's a solution to the existing problem which the semiconductor and hardware industry is currently facing. AI agents are autonomous system which perceives in an environment, takes actions, does complex reasoning to achieve a specific goal. With agentic AI, it's even more capable enough. It can handle repetitive tasks more efficiently by dynamic decision making and accelerate development cycles and chip designing. Let me walk you through a revolutionary product, IntelliDesign Companion, an AI powered Copilot Assistant. The target personas are chip engineers, the verification teams, the semiconductor startups, to name a few. The objective of using this tool is to give an expert guidance right at your fingertips, reduce the design cycle, and improve the overall efficiency of chip designing. Let me bring the architectural overview of this product. It is modular in nature and each module has a specific functionality like multi-agent, multimodal, and it also showcases different agentic patterns and workflows which are executed using frameworks like Agno, LangGraph, CrewAI, and Autogen. I have illustrated multiple use cases revolving around Copilot agent, and my very first use case is building a multimodal agent using Agno as the framework. What is multimodality? It is a concept in which the AI agent takes multiple forms of input like text, image, audio, video, etc., processes the user input, and generates a response. Let me explain the quintessential elements in the architecture of multimodal model. I have used Gemini 2.0 Flash LLM in this use case. The core architecture is the visual transformer. It consists of two main components, the patch embedding and the transformer encoder module. The patch embedding module takes input image and divides the images into non-overlapping patches. Each patch then is then projected into a lower dimension embedding space, yielding series of embeddings. The transformer encoder module, it's a main component and it has several stacks of multi-head self-attention and a feed-forward neural network. Self-attention mechanism pays attention to different parts of image and the output is passed to a feed-forward neural network with a softmax activation function. The final output is going to be the probability distribution or a class label. Here's a flowchart of Agno multimodal use case. In the very first iteration, it is taking an image of a circuit diagram, or you could be uploading VHDL or Verilog code as an input. It analyzes the IC images, answers the user query, suggests optimization and improvement techniques. Finally, we have a report. Let's dive into the use case 2, where I'm going to be illustrating a Copilot agent using CrewAI as the agentic framework. Here, multi-agent CrewAI collaboration is illustrated, where each agent has a specific role. Roles could be researcher, it could be a writer, and the goal, which is nothing but an objective, and a backstory, which explains about the experiences and the background. It makes use of several tools like web search, calculator, weather tool, or it could be an external API. It uses LLM to solve a real world problem. Here in this use case, I have used 3 different agents. Each agent has different functionality. AI model agent helps in debugging, optimizing, and simulation. Design agent is going to be reviewing, suggests further optimization, and generates a formal report. We have an orchestrator agent which orchestrates the other 2 agents and does the final review, comes up with a design report. In the use case 3, I have built an agentic chatbot using LangGraph as the framework. The components of LangGraph are state, nodes, and the edges. These nodes are connected with the edges. Nodes are nothing but the actors performing a specific task, and edges are going to define the relationship between the nodes. LangGraph facilitates coherent task orchestration between the nodes using a graph state. Here's a flowchart. It's going to take the input from an user, updates the state of the memory information. If required, it is going to use a tool to gather more factual and grounded response from external world, generates or synthesizes response. In the use case 4, I have illustrated agentic patterns and workflows. These agentic patterns are a sequence of actions or behavior exhibited by an agent to pursue a goal within a simulated environment. There are different patterns: tool calling, multi-agent, reflection, and planning pattern. I have used multi-agent and tool calling pattern in my illustration. In my next use case, let me explain what is an agentic workflow. It is a series of predefined steps which are executed by an LLM by using a tool, by using an LLM and a tool. The workflows are orchestrator worker, evaluation optimizer, prompt chaining, and parallelization. In use case 5, I have used a multi-agent, I have used AutoGen as the framework, and I've illustrated a multi-agent pattern. The reason why I've chosen AutoGen is because it handles dynamic adaptations to a specific design requirement. It allows customization and orchestration. Let's discuss the results and the impact, the problem matters, and the solutions implemented. It has pretty much automated several design aspects. It has brought in document automation. It provides real-time dynamic design assistance. It also automates simulation and verification process. The benchmark clearly states that the Copilot agent is taking just 45 minutes to complete an RTL draft, which otherwise used to take around 4 hours with traditional design. This is very evident, and it improves the efficiency, performance, and reduces the delays in production, hence brings down cost cutting, which is going to have a major impact on startups and small design teams. Traditional designs were more prone to errors, which are eliminated by using this tool. It has proven that it has 4x times improved the accuracy. Let's dive into technical implementations and innovations. By implementing modular architecture from simple validation task to a full-fledged design, it has scaled very easily. New agents can be seamlessly integrated into the existing workflows, enabling scalability. Exploration of different agentic patterns and workflows has significantly proven to be a groundbreaking technology in chip design and semiconductor ecosystem, and it has redefined the chip design process. And use of multimodal agent with support of different modalities like text, audio, video, and images all at once. It has proven its technical innovations. Let's discuss future works. We aim to integrate this UI directly as a plugin based into the chip design IDEs and workflows. Also enable custom agents training on internal specification. Integrate this with industry standard formal verification tools, commercial EDA platforms to support real work production grade chip design workflows. Here are few reference links which you can feel free to check them out. This concludes my demo. We have seen how an LLM powered Copilot can transform the chip design workflows and with intelligent automation and assistance. Hope this has enlightened you. This is an eye-opener session. Thanks for giving me an opportunity to present this. Thank you.